This is video 2 for October 17th and 18th. We solved this problem. I said we were going to do 3, but I think this situation here takes care, of other problems that we were going to do. So this will be the second and last video for October 17th and 18th. So here, an organization in town is hosting a fundraising event under a large event tent in a park. And the people that supplies the tent, they recommend the angle between the cables holding the tent and the ground should be between 25 and 50 degrees. The length of each cable holding the tent in place is 13 feet, and the distance from the base of the tent and where each cable is tied down is 10.8 feet. Is the angle created between each cable and the ground within the recommended range? So we're trying to figure this out. Also, I wanted to give a shout out to individuals that did something over and beyond of what they're supposed to do. Miss Brooklyn, I'm not going to say last name, and Mr. Jalen, I appreciate what you're doing. Appreciate doing what you're supposed to do and beyond that. So I appreciate that. Told him I'd give him that. Anyways, we want to solve this problem, solve for the angle, make sure it's in the recommended range. Here, let's go ahead and fill in. This is a beautiful tent. Spent a lot of time working on the tent. Okay, here's the tent. Here are the posts holding it in. Cable is tied in the ground by something. We have a right angle here. The length of each cable holding the tent in place is 13 feet. And from the base of the tent, so from the base of the tent to where the cable is tied down is 10.8 feet. And we're trying to figure out if the angle created between each cable and the ground is within the recommended range. So from the cable to the ground, we don't know what this is. We're going to try to solve for that and see if that theta is within our recommended range. So what we're going to do, well, what would probably be most useful to use, we could use Pythagorean's theorem to solve for this side. But here, if this is our angle theta, we're given our adjacent side to theta and the hypotenuse. So it might make sense to use cosine and say cosine of theta is 10.8 over 13. And if that's the case, then we want to get theta on its own. We're solving for theta. If we do that, really want to get rid of cosine here to get theta on its own. To get rid of cosine, what we would do is do the inverse of cosine to both sides, and that would be cosine inverse. This is also equal to arctan cosine of 10.8 over 13. Excuse me. And if you do that, then what we can do is we can put either of these into our calculator. So you can do 10.8 divided by 13, take the arc cosine of that, and if you do that, you would solve and get that theta equals 33.82 degrees. So this angle would be 33.82 degrees. That it is within our recommended range. So yes, we're good. It's in our recommended range. We can go ahead, use that tent, and use the inverse trig functions to solve that problem. Again, all the other problems are similar to this. It's just the drawing of the problems that might be a little tricky. If you ever have questions about these, please feel free to email, contact me, whichever way possible. Whatever is most beneficial for you, please email me, contact me, ask the questions.